Hi everyone. So this lesson will be about counterexamples. Let's first read a definition to make sure that we understand it. An if-then statement is false if an example can be found for which the hypothesis is true and the conclusion is false. So we're looking for a conditional where the first part is true, we want it to be, and the second part, the conclusion, is false. And if such an example makes this the case, we call this a counterexample. So the first example they provide for us in purple. They say if x squared equals 49, then x equals 7. The answer would be x equals -7, because if we check the first part, -7 squared, if we square it, it is actually equal to 49. So that's true. But if we look at the second part, x equals 7, the value of x equals -7 is not equal to the +7, right? So this part would be false. And this is a first example for us in this video, seeing what a counterexample is. Let's look at some other examples on the bottom and do some problems. So you're asked to provide a counterexample for each statement below. In the first case, let's try to draw some pictures of maybe plus. So they tell us AB is congruent to BC, then B is the midpoint of segment AC. Let's draw some pictures to visualize what that might look like. So here's AB. If we want to make it congruent to BC, we could maybe draw something like this. So make the dots visible. And you can sort of see that these are congruent, but B is the midpoint of AC in this diagram that I've drawn. So this is not a counterexample. We're trying to make the conclusion, the second part of the sentence, false. Let's try to draw a different case. So we can draw AB like this. And maybe we can do BC this time like this. So here we do have the segments again congruent. Now, if we were to look at the midpoint of segment AC this time, so let's draw it in blue, the midpoint's actually here this time. So point B is not the midpoint of AC in this picture. It is not always the case that just because AB is congruent to BC, that B is the midpoint. We have successfully found a counterexample based on this diagram that I've drawn. So we'll label it counterexample. And let's try another case below, number 3. So if n squared equals 5n, it says, then n equals 5. Let's try a case where we can find a value of n that can make that first part, the hypothesis, true, but it not be equal to 5, so it'll make the conclusion false. So we'll try to copy the equation first. What happens when we solve? When we solve something that has something with the second power, it's called a second degree or quadratic equation. So we're going to try to find all the values. If we try to divide by n, what would happen is that we would get n equals 5, which is giving us the same result as what we started with, n equals 5. That's not a counterexample then. We actually do not want to divide by any variables when you're solving algebraic equations, because when we divide by variables, we risk losing solutions. So we lost a solution that would have been a good counterexample for this problem. So we should probably try something else. Dividing by n would, hide the solution that we really want. Let's do it below. Copy the equation again. Instead of dividing by n, let's subtract both sides by 5n. So we'd get something like this. N squared minus 5n equal to 0. Notice that the terms on the left-hand side both have n, and we can then therefore factor it out and rewrite the expression on the left-hand side as n times the quantity in parentheses n minus 5. So if you might recall, when two quantities multiply to equal 0, let's try to look at a case like that. Let's say a times b equal to 0. What that implies by the zero property is that one of those quantities must equal 0. So either we know A equals 0 based on that product, or B equals 0, right? So one of those quantities has to equal 0 for the product A times B to be equal to 0. We're going to use that idea, the zero product property. Zero product property. We're going to use that when we're solving the quadratic on the left. So if n times the quantity of n minus 5 equals 0, we know n equals 0, or n minus 5 equals 0. If we solve for n in the first case, we know n could be equal to 0. If we solve for n in the second case and isolate n by itself, n would equal 5. So these two are the solutions for the original equation, n squared equals 5n. So the one that we want is the one that contradicts the last part of the original sentence. And that one is n equals 0. Although both of them, n equals 0 and n equals 5, solve this equation, we are trying to find the one that makes the first original statement, the first part, the hypothesis, true. So let's check. If we put 0 for the n value, square it, and we check it with 5 times 0, and we're testing it, the left side would be 0 squared is 0, and 5 times 0 is 0. It is true. However, if we put this value of 0 in the second part of the sentence, 0 equals 5, that is not true. This is a false statement, right? So that's exactly what we want. For number 3, we will write the counterexample is n equals 0. And we can box that so it's more visible. So there you go. Hopefully this helps you understand counterexamples. Try number 2 and number 4 on your own, and that's the end of this video.